Okay, well, my name's Philip Brauer. I'm in the Department of Biomedical Sciences at Creighton University. My primary teaching responsibilities are in gross anatomy and embryology, and I teach those subjects to nurses and medical students. I had a professor that made quite an impression on me, both in the sciences, how I got into embryology, but he was also a very good teacher. And I had opportunities after I took his courses to actually TA in the classes, and I found I liked teaching, I liked that type of interaction. And it also sparked my interest in the development of biology, and that's what when I went into graduate school, my research actually was in development of biology, embryology. I think a lot of the diseases that we had no idea where they came from are being revealed, mechanisms for that, and I think they're finding also that embryology is actually something, if there's something goes wrong, it actually shows up in pathologies, not just at birth, but actually later in life. So some of the in ovo environment and history actually is kind of remembered when you get to be my age, maybe. And so I think the connection between what's learning in the basic sciences is having a big impact in the clinics, maybe more so than some people in the clinics realize. So it's really dynamic, it's fast. Things go out of date really quick, or questions that have been around for a long, long time, for like a century, are actually being answered now. So it's an exciting time to be a developmental biologist and to be looking at embryology as a subject. It doesn't end at birth. Some of the strengths of the book that attracted me then, and is still something that's important to the authors, are the illustrations, because it's really hard to convey a three-dimensional, much less a four-dimensional object in a textbook, and so the figures are really important. The other thing that it did, that it tried to do, that we're still expanding on, is relating some of the findings in molecular biology and genetics and really applying it to, or revealing that in the text in terms of the subject of embryology. Before, many texts were fairly descriptive, but there wasn't as much about the mechanisms, and it's the mechanisms that, when they go wrong, actually end up causing a congenital defect, for instance. So that's one of the things about the book that is still true and very important to the authors right now, including myself, is the quality of the images, the merging of the molecular and genetics into the text, the merging of presenting the molecular biology, or parts of it, and genetics into our understanding of embryology. So I think I wanted to be involved with that, and so did the other authors. There was a gap, and I still think there is in many regards, to address and merge those two. And the book is set up such that in the beginning of each chapter there's a timeline with basic high points. You sort of teach it in piecemeals, one organ system, the next organ system, but it's hard to get a sense of when all these things are occurring at the same time. But having a timeline in the beginning gives them an idea, well, what happens in the first month, second month, third month. Then there's, I would think of it as almost an abstract in the beginning that gives a kind of an overview of what's going to be covered in that text, or that chapter, I should say. And then what's new in the fourth edition were clinical tasters, or clinical scenario in the beginning, and that's where Steve, Dr. Biles' contribution is really good, because he's a pediatric geneticist, and he knows the ins and outs, I guess, of that, and it's really important.